Hi everybody, today, oh goodness, sorry, I'm trying to click something and talk at the same time and it's not working out. Great first impression, Miss Scully. Alright, so today we're going to do day 4 notes. It's written on the top of your page. This is, we're only doing 5 days of notes, so we're almost done with this unit. Yay! And then it's spring break, yay! So, quadratic formula is the last method that you can use to find solutions. So, we've already talked about graphing, factoring, now quadratic formula. And let's just go ahead into it, because it's kind of going to, otherwise I'm going to cover things twice. So, here's the quadratic formula. It says negative b plus or minus the square root of b squared minus 4ac all over 2a. This formula is going to be given to you on the formula sheet, so you do not need to memorize it. However, you will probably have memorized it by the time you even take the test or the SOL. So it's going to be ingrained in your brain forever. You'll never forget it, whether you want to or not. So let's talk about the parts here a little bit. So I'm making a lot of hand gestures, but you guys can't see any, so just imagine my hands flying everywhere. Okay? This negative b over this 2a. That is actually the part that you're going to use for a line of symmetry. That is really, really important because that will help you in, like, if you forgot the line of symmetry thing, it's going to be on your formula sheet, but it's not going to say this is the line of symmetry formula. You have to know it's this part right here, the front and the bottom. Okay? The plus minus part actually tells us that's how we get two answers, because we're going to do it once with the plus sign and once with the minus sign. And I'll show you how to streamline your work so you aren't doing like twice the work. Okay? And then this part under the radical, this is called the discriminant, which is part of these notes. The discriminant actually helps you figure out how many solutions you're supposed to have. So if you didn't have a picture or you didn't have access to your graphing calculator, you can use the discriminant and be like, oh, well, this says I should have 2 answers, but I only got 1. I made a mistake. I need to fix it. Big hand gestures. Okay? So, I know that was really weird, and you guys aren't even around me, and I know it's weird. So, let's talk about solving quadratics using the quadratic formula. So far we've solved quadratics by graphing and by factoring, like I said. Okay? The last method we're going to do is using the quadratic formula. So this is how you do it. You're going to put your quadratic in standard form. That is key, standard form. So you're typically going to have it equal 0. If it equals y, that's fine. That's still standard form. Either y or 0 is what you want. You're going to list out what your a, b, and c are. Remember, sometimes if you don't have a term there, then that means that letter is 0. Okay? So write out your a, b, and c. You're going to plug your a, b, and c into it. And then you simplify. That's it. That's all you got to do. So let's do an example. So I just wrote the quadratic formula up here in the corner so I can remember it and I have a reference for it. So the very first thing I need to do is put it in standard form. So this says x squared plus x equals 12. I need it to equal 0. So I'm going to subtract 12 from both sides. Now, I don't have a like term to combine this negative 12 with, so I'm just going to put it on the end. So my standard form is actually x squared plus x minus 12 equals 0. So now it equals 0, it's in standard form, I'm good to go. I can find my a, b, and c. A is a number with the first term, and that is actually an invisible 1. B is a number with the second term, which is also an invisible 1, and c is my constant, which is also known as your y-intercept. It's negative 12. So now that I know what a, b, and c are, I can plug it into this formula. So I just go ahead and plug it. I put parentheses around anything and everything just to be sure, especially around this negative b. So now I'm going to go ahead and simplify. So I'm going to simplify the stuff inside first. And I just did it kind of all in one step. I did the 1 squared and the multiplying here. And I got 1 plus 48 because the negative 4 and the negative 12 multiplied to be a positive 48. And I did the multiplication on the bottom as well and just got 2. So now I'm going to add the stuff in the, what is this called? A radical. I'm going to add the stuff in the radical. So I can have one number to take the square root of, which would be helpful. And so it's now negative 1 plus or minus the square root of 49 over 2. I can do the square root of 49, which is great. So this is one, if it's not a perfect square, go ahead and do it in your calculator and get a decimal and just round your decimal to the nearest hundredth place. Okay? It is possible that you will have decimals though. Alright? So that was my phone going off, but I'll ignore it. So now I have -1 plus or minus 7 over 2. Now, here's the part where you kind of have to split it because you're dealing with two different operations. You got a plus and a minus here. So I'm going to split it into two different equations. And I'm going to move all this stuff out of the way because I need this space over here. So I'm going to write it once with the plus sign and once with the minus sign. So I have -1 plus 7 over 2 and -1 minus 7 over 2. So instead of doing all of this work the same, like twice, one for each sign, I'm just going to split it once I've simplified as far as I can. And then I can just do the little work. So now I got to do -1 plus 7, and that actually equals 6 over 2, which simplifies to 3. So 3 is one of my solutions. Now I'm going to do -1 minus 7, which gives me -8 over 2, which simplifies to -4. So that means my solutions are 3 and -4. And the reason I wrote it this way is because sometimes solutions are written as a set with braces. They mean the same thing as saying x equals 3, comma -4. I'm not going to take points off for it if you write it this way versus, or if you write it x equals, it's totally fine. They both show me that you know how to find zeros. I just wanted to show you a different way of representing the answer, so if it's a multiple choice question, you're not confused. Okay? That was a lot of talking. Now, I gave you 2 try on your own, to literally try on your own. So the key word there is try. Okay? First one, I gave you the formula, and I gave you like the setup to like help you figure out what you should do first and fill that in, because it helps you organize your thoughts. The second one, I did nothing for you. I didn't give you anything. So if you want to use that strategy of the organization, go for it. You don't have to, but if you get it wrong, we probably know why, because you're not using the organization. Okay? So the next part is all based on the discriminant, which I told you about. It's the part under the radical. It does not include the radical. Okay? But it can help us determine how many solutions there are for a quadratic equation before we even try to solve it. So this might help you streamline your work, or it could help you check your work to make sure you have the right answer rather than going to the graphing calculator. Okay? It's the stuff under the radical, not including the radical. So here's the thing you need to know about it. So it's b squared minus 4ac. You're still going to need to know a, b, and c because that's what you're plugging in here. Now, if that number that you simplify to is less than 0, that means you have no real solutions. Because if you plugged it back into the quadratic, you can't do the square root of a negative number, so it's not possible. So that means you're going to have a parabola that does not touch the x-axis. Okay? And if you get one that equals 0, you have one real solution, because if you do the square root of 0, that's still 0. So it doesn't matter if you're adding or subtracting 0, you're going to get the same number. And if you get something greater than 0, you're going to have 2 real solutions, because when you do the square root of it, you'll have something to add and to subtract. Okay? So if it's less than 0, nothing. Equal to 0, 1. Greater than 0, 2. Okay? So here's an example. Determine whether the graph intersects the axis at 0, 1, or 2 points. So I am going to fill in this b squared minus 4ac, but to do that, I need to know what a, b, and c are. So I'm going to write it out. A is 4, b is -12, and c is 9. So I go ahead and plug those numbers in. I'm going to use parentheses every single time. Okay? Because, and if you type it in the calculator, which you can, you should use parentheses around it. Because if you just type -12 squared without parentheses, it's going to give you -44. But that's not really what it is. You're squaring the -12, not the 12 and making it negative. Okay? So -12 squared is actually 144. And then I did 4 times 4, it gave me 16. Now I'm going to do 16 times 9. I also get 144. So I get 144 minus 144. That equals 0. So because it equals 0, that means I only have one solution. Okay? It's just going to touch the axis. And if they ask you what is the discriminant, your answer would be 0, because you're telling us what that number is. Okay? So you have a try on your own as well. It's already set equal to y. which means it's already in standard form, so you're good to go. The next example, which says find the number and type of solutions, we're just finding the number of solutions. Forget about the type. Because you guys are only dealing with one type, which are real. You'll deal with imaginary when you get to calculus. I'll preview for you. So here we're going to go ahead and make it into standard form first. We're going to get it to equal 0. Okay, so here I'm going to subtract 1 first from both sides. I get 3x squared minus 5x minus 1 equals 0. I'm still filling in this discriminant, b squared minus 4ac, so I need a, b, and c. A is 3, b is negative 5, c is negative 1. So that's what I'm going to plug in here. So I have negative 5 squared minus 4 times 3 times negative 1. So negative 5 squared is 25. Negative 4 times 3 gives me negative 12. Negative 12 times negative 1 gives me positive 12. So I've got 25 plus 12. That equals 37. So my discriminant is 37. Now that number is greater than 0. So that means you will have 2 solutions. So it's going to cross through the axis twice. Okay? And then you guys have one try on your own to get it to be standard form first, and then find the discriminant and tell how many solutions there are. That's the entire video. If you guys have questions, please write them down and be sure to ask them in class. We will do an activity with this to practice even more. And that's it. You guys have a good day. I will see you next class, and bye.